Good evening, everyone. So we were introducing this GSM architecture in our previous sessions, and we have completed that to an extent. And it is the time to concentrate and study a little bit on something called as radio evolution, how the radio management is was happening in the old technology networks, like especially in GSM and all that. So we would be looking into that now. Okay. Sorry. So uh, we were having a technology called as a 1G technology even before the 2G technology that we are studying, like the GSM one. In 1G technology, how the radio was looking like. So we can see a brief summary of that here in this slide. So this 1G technology was called as Advanced Mobile Phone Service that time, and it is a analog system basically. So what is the meaning of analog signal? What is the meaning of analog system? Typically, the users generate the voice data. Your speech would be in analog format. So what they used to do in this 1G system was the analog data. They started sending that analog data directly by converting it into analog radio signal. They'll transmit that. So that was the scenario. Of course, this technology, 1G technology, was using something called as circuit switching mechanism, circuit switch mechanism. So what is this circuit switching mechanism means? Before we start a conversation or having a call, there must be a logical circuit established between your mobile phone and the other mobile phone which is in conversation. So there must be a circuit established. It could be a logical circuit or it could be a physical circuit, but a circuit must be established. That's one requirement. Only after the circuit gets established, you start sending the data. Of course, the data would be analog data, which will be transferred in the analog format by using the analog radio signal. That was the idea. And this particular system is working in FDD technology. What does this FDD stands for? It stands for frequency division duplex. Meaning is you are going to use two frequencies. One uplink frequency you have to use and one downlink frequency you would be using. Why? When you have two frequencies, one for uplink and one for downlink, you will be able to perform both uplink and downlink at the same time. You can do that. You will have that uh, possibility when you have two frequencies operating. If you are operating only with one frequency, you can either do a uplink or you can only do a downlink. You cannot do both the things at the same time. But because we wanted to have that freedom to perform uplink and downlink at the same time, to have a real-time feeling of a call, so they thought that FDD would be a better option. So to have two frequencies, one for uplink and one for downlink. Now, how these frequencies working, that I will explain first. So we have a concept called as FDMA, frequency division multiple access. So they used to have this FDM concept at cell level. What is the meaning of using the FDM concept at cell level? Operator buys some X amount of uplink frequency, X amount of downlink frequency from the government. Now that uplink frequency and downlink frequency that is purchased by the operator would be divided into small pieces. So we would be allocating one piece of downlink frequency, one piece of uplink frequency for each cell. So every cell, as you can see on the left hand side picture, every cell has got two colors, where those two colors representing one is representing uplink frequency and the other one is representing downlink frequency, those two colors. So if you buy a chunk of the frequency would be divided into smaller pieces, and we would allocate one piece to one cell. Okay, fine. What happens next after this? In every cell, there would be lot of users. There would be lot of mobile phones operating. So what do you allocate to each mobile user again? So again, we used to apply FDMA in this 1G technology. They would apply this FDMA technology itself, even at the user level. What is the meaning of using FDMA again? So whatever the sub-frequency that is allocated to um, each cell, so this sub-frequency will get further divided into sub-frequency, and one piece of downlink frequency and one piece of uplink frequency would get allocated to one user. For example, if you take a generic example with numbers, let us take that we are having 7 cells here. Let us assume that operator has bought 1.4 megahertz frequency band from the government. So he is buying 1.4 for downlink, 1.4 for uplink. Now this 1.4 megahertz band is getting subdivided into 200 kilohertz sub bands. So we totally have 7 200 kilohertz sub bands. Each 200 kilohertz is got allocated to a cell. Of course, we have one 200 kilohertz for downlink, one 200 kilohertz for uplink. So every cell is having 200 kilohertz bandwidth. One for uplink, one for downlink. Two 200 kilohertz available for every cell. Now, under that cell, there could be a lot of users who are operating, who are working in that cell. There could be a lot of users. Okay. Now, what do we allocate to these users? What do we allocate to these individual users under that cell? This 200 kilohertz may be further divided into pieces. For example, if there are like 10 users there under each cell who are working live, maybe we can divide 200 kilohertz into like 20 kilohertz each. And for every user, we would allocate 20 kilohertz to the user, like 20 kilohertz in uplink and 20 kilohertz in downlink. We could allocate it. So uh, it is like two levels of division. The frequency is getting divided multiple times, cell level ones and user level ones. This is the easiest concept that we can survive with. Okay, so this is the one that they were using in 1G technology, even before GSM. This was. We don't learn any further than this in 1G. But by the time we have come into 2G in GSM, some changes have occurred. What changes? What is the first change? They thought of moving from analog data to digital data. That was the first change. It is a digital network. Meaning is your devices will be converting the data that humans generate into digital data, into ones and zeros. Your voice data also would get converted into ones and zeros. What is the advantage with the digital data? Your digital data will have a lot of advantages like compression and decompression. You can perform encryption. Okay, you can do many other things with the help of digital data, which you cannot perform on analog data. That was the biggest reason to move into digital data. For example, if it is analog data, you cannot compress analog data. Its fundamental size will be the same. You can never typically compress it in any way. Even if you want like to compress it by using any advanced scientific methods, the amount of compression will be very minimal in case of analog data. So if your voice is in voice format, the compression would be very low.
Sir, actually, I have one query here. In 1G, you said, sir, there are two different frequencies are using for uplink and downlink, right, sir? So here, but you are saying, sir, 20 kilohertz for uplink and downlink. How is it, sir? Is it the upper band for uplink and lower band for the lower downlink, or is it different?
No, don't worry about what the color and everything. I will come to uplink downlink. I have not yet gone to that level in 2G. Let me come to that in a minute. I will explain that. First thing that I'm explaining is this digital part. Let us look into that section. For example, if you are keeping your records, like for audio records and all that in analog format, you cannot perform any activities on that analog data. But normally, when you are actually like converting your digital, your audio data into digital format, you can do lot of magic on that. For example, when you listen to some of your, your favorite movie stars singing, you will feel like they are singing it really good. You think that way because when you heard that audio, it felt really good for you. Okay, very good, nice. Then when when you heard them sing in the real life, you might actually like run away from that place. Then you will be thinking, hey, what is the change? In the movie, it looked really good. So what typically they do is they'll convert that person's voice into digital data, and they will do lot of changes on that because digital data allows that allows you to make a lot of modifications on your data. So that's the basic advantage you are getting with this digital data. Okay. Second point, in 2G technology also we would be using this circuit switched mechanism. For uh, destination, there must be a uh, circuit established between the source and destination. Okay, great. Then we are again using FDD concept here. What is the meaning of FDD concept? Again, the same story. Any mobile which is operating must have a uplink frequency and downlink frequency, separate uplink frequency, separate downlink frequency must be available for the mobile. That's what we term it as FDD, frequency division duplex. So that you can send if you are talking, your voice can come go out at the same time. If your friend is talking, you can actually hear his voice. Both can happen at the same time. But for example, you and your friend are arguing on the phone, nobody is stopping, both of you are speaking at the same time. So what happens? Well, whatever you are speaking will go out, whatever you are getting from your friend you will keep getting it at the same time because you are working on FDD, frequency division duplex. Two different frequencies are working for uplink and downlink. It is not the same frequency. So that is the basic concept of FDD. Now, in 2G, what change happened in the technology when you compare it with the 1G? At cell level, even in our 2G, we were continuing this FDMA concept. That means at cell level, operator will have to buy 1.4 megahertz for downlink operation, 1.4 megahertz for uplink operation, and divide that into 200 kilohertz each, and allocate 200 kilohertz to each of these cells. So if you buy 1.4 megahertz totally, you will be dividing that. So you are allocating 200 kilohertz for this cell, and another one for this cell, another one here, another one here, another one here, another one here, and another one here. So totally you have got uh, 200 kilohertz, which is equal to 1.4 megahertz operator has bought. That is downlink. Now, operator should have another 1.4 megahertz frequency for uplink. Even that uplink frequency also would get divided into seven parts. So you have one here, you have one here, another, and another one here, another one here. So if you take any cell, so you have 200 kilohertz downlink available, you have 200 kilohertz uplink available. Frequencies available. So whenever there are two frequencies available, that is what we are typically calling it as FDD, frequency division duplex. Okay. So we have done the cell level division also by using FDMA. Great. But what do we do for the individual users? At user level in a GSM system, they have decided to use TDMA technology instead of second FDMA. If you take your 1G technology, at cell level they are doing FDMA. At user level also they have done FDMA. That means this 200 kilohertz that whatever is allocated to a cell, we will further divide it into pieces. One piece will be allocated to one mobile phone who is operating at the same time. That was in 1G technology. So every user will get one piece of downlink frequency and one piece of uplink frequency. Every user would get that one piece uplink, one piece downlink, which is uh, which is on a call or whatever. That was 1G. But in 2G, what modification they have done? Instead of using FDMA at user level, they have decided to change the technology to something called as TDMA. So what is happening in the TDMA at user level? This 200 kilohertz frequency or the subfrequency that is allocated to any cell that will never further get divided. But what do we do? What do we allocate it to the users? If at all you are allocating this 200 kilohertz frequency, we allocate the entire uh, frequency to a single user. Then you will get the immediate doubt. Hey, if you allocate the entire 200 kilohertz to a single user, what about other users? How will they work? What do you allocate to the other users? That is, here is where the trick. When you are going to allocate the entire 200 kilohertz to one user, you would put a condition. You tell to this user that, hey man, I'm not giving this entire 200 kilohertz frequency for full time. I'm not giving it to for the full time. What I'm doing then? I'm giving the 200 kilohertz entirely for you, only for a smaller duration. You have to use it. After that, I will take it away from you and I'll give it to somebody else. So it is kind of it will be working in some kind of a round robin way. It's kind of it will work in circles. So you get the 200 kilohertz for some amount of time, for very small amount of time, and then that resource will be allocated to another mobile. Then it goes from that mobile to another mobile. Then it goes from other mobile to that mobile to another mobile. Like that, it keep going among the mobiles. Finally, after some number of slots, it will come back to you again. That means you will be getting it only once in a while. Anytime you will get to use the entire band, entire 200 kilohertz you can use, but you will not be getting it for the entire time. You will be getting it only for a small duration. That is what is the meaning of TDMA, time division multiple access. So why this was advantageous over the previous FDMA plus FDMA technology? Why this is advantageous? In case of FDMA plus FDMA, first 200 kilohertz is divided into 25 kilohertz each, and each 25 kilohertz is allocated to one mobile phone. But the problem in that is, if you allocate 25 kilohertz to each user, for example, we are doing it that kind of a division. In the middle of the frequencies, we need to leave some guard band, because if you don't leave the guard band between two mobile phones frequencies which are one next to the other, there could be some kind of a interference will be there between those two users because frequencies are one next to the other. So they thought that, hey, if we are dividing the 200 kilohertz into 8 pieces, you are allocating 25 kilohertz to each user, but we cannot allocate the entire 25 kilohertz to one user because we are going to waste some guard band between every two frequencies or every two sub frequencies. We are going to waste some guard band or some guard frequency. We have to leave it just like that without allocating it to anybody in order to avoid the interference because adjacent frequencies can have interference. They want to avoid this. So how they decided to avoid this? By using this concept called as a TDMA, time division multiple access. What happens here? Your 200 kilohertz frequency that is allocated to the cell for both uplink operation and downlink operation is never going to get further divided. It is going to get allocated entirely to a single mobile phone user at any moment in time. But we are not allocating it permanently. We are going to allocate it to a user only for a small duration. And then after that we give it to somebody else, some other user. It will be circling among the users. Because the entire frequency we are allocating it to a single user, you don't need to leave any frequency guard bands. You don't require that because the entire frequency is getting used by a single user. You don't need to leave any guard band, so you can avoid the frequency interference problems here because you are not dividing this frequency into sub frequencies. The entire frequency is getting allocated to a single user. But even if in this TDMA, how many um, frequencies you are going to get? Because we are using FDD concept, you must be getting two frequencies. One uplink 200 kilohertz, one downlink 200 kilohertz. You should get that. Okay. Now I'll allow your question. Someone was asking a question. I can ask your question now if there is anything related to FDD or anything else. You have any question on that? Okay. I hope it's solved. Fine. All right. So in case of 1G technology, it was frequency division duplex. Two frequencies are operating for every cell and every user. But at cell level, um, we are doing the divisions for every cell. And in 1G, we are doing the frequency subdivisions for the users also. But in case of 2G, we are not doing the frequency subdivisions for the users. Instead of that, we are keeping the frequency as a single piece. We are allocating that single piece to every user only for a smaller duration. Okay, that is why this is called as TDMA, time division multiple access. Immediately you will get the biggest doubt in your head as soon as I say that it is a TDMA. What is the doubt that pop up into your head? Normally, in most people's head, this will pop up immediately. Hey, when we are having a call, you are talking continuously. Now, if a TDMA slot is allocated for you only for some duration, and after that it is taken away, and if it is allocated to some other user, how can you continuously talk? How can we have your call ongoing continuously when you are not having your resource? That is the immediate question that comes into everybody's head the moment we listen to this concept. Because in FDMA plus FDMA, we are getting the 25 kilohertz continuously So we'll not have the doubt because we are having the 25 kilohertz, whatever the sub frequency that is allocated, you are continuously having it. We will feel satisfied as a human that, oh, we have a continuous frequency available, so we can transmit anything we want it all the times. We can receive anything we want it all the times. But by the time I tell you this TDMA concept, hey, we are not getting the frequency continuously. We are getting it only once in a while. How can we talk continuously, or how can you get your friend's voice continuously from the other side? How can you get it if you are not having the frequency available continuously? Okay, so that is where we have to understand a little logic. You are speaking continuously, that is good, but what your phone is going to do is your phone is going to capture your analog voice data, and it will be converting into digital frames. It will be converting into digital frame. Let us suppose that your phone is converting your analog voice data into digital frames, nothing but ones and zeros. If you put them together, we call it as digital frame basically. So it is a package of digital data, ones and zeros. Inside that, your voice related information is hidden. Now, if you want to send, if your phone is packaging the voice frames, we have to think about one important aspect here. What is it? How often your mobile will convert your voice into digital frames? How often will it do it? Let us assume your mobile will be converting your voice into a digital frame every 50 milliseconds once. It is converting. Let us assume it will generate a voice frame every 50 milliseconds once. I hope you all know that 1 second is equal to 1000 millisecond. When I say 50 milliseconds means it is approximately equal to 1 by 20th of a second. It is 1 by 20th because I am taking 50 milliseconds there. Okay, now what is the meaning of that? Is so you know that your phone is generating a voice frame every 50 milliseconds once. So what kind of a arrangement we can do if it is this TDMA concept? We can do arrangement in such a way that your mobile would be getting a resource like every 50 milliseconds once. We can make that kind of arrangement because you don't need your resource continuously. Only when you have a frame generated to send that voice frame, you need the resource. For example, every 50 milliseconds once, you get your voice for you get your resource for let us just blindly take it as 5 milliseconds. You get your resource only for 5 milliseconds. For the next 45 milliseconds, you won't get the resource. You don't have your frequency allocated for you. It is allocated to some other mobile phones. You are not having it. It is allocated to somebody else. Then, when it is allocated to somebody else, won't you be speaking? You will be speaking. Your phone will be capturing your voice data, and it will be in the process of converting that voice data into a digital frame. It has already converted your voice into a digital frame now, and it will again generate another digital frame after 50 milliseconds. Now, once you have already sent out your present digital frame, to send the next digital frame, you have to wait for 50 milliseconds because your mobile is going to generate the digital frame only after the another 50 milliseconds. So they are going to use this as their advantage while you see, to um, allocate the radio resource to the mobile phone to the mobile phones, not continuously but every once in a while, because your even though you are speaking continuously, normally you will be visualizing in your head that hey, when I'm speaking continuously, my phone is also sending my voice data continuously. No, it is not. Your phone will be converting your voice data into digital format every some X amount of time. It will be generating a digital frame. Whenever your phone is ready with the digital data, you need to have a resource. You need to have that radio frequency available for your phone so that your phone can send out that data. So they thought that we could implement this TDMA technology because even though the humans will be visualizing that they are speaking continuously, but in reality, the phones will be generating the data in patches. They will not be generating the data continuously. So we could use that for our advantage and allocate the resources for each mobile in a slot wise mechanism. So you will get the resource in one slot. For the next some n number of slots, the resource won't be yours, it would be somebody else's. But after n number of slots, you again get the resource for yourself. By the time your phone is ready with another voice frame, it will be, it is ready to send that voice frame. So that's how this TDMA technology works. Time division multiple access. So your radio frequency is not allocated to you continuously. It would be allocated to you in slots, in not continuous slots. They'll be in ran like some kind of a round robin way. It would be allocated. I hope I made that concept clear. Now we are going to learn some GSM radio technology related things. These are very much important for us to understand uh, the basics of radio technology concepts. We would like to have that idea completely so that we will be able to learn LT in a easier and a better way. Okay. So what are we going to have here? We'll see. We will take the typical situations. Typically, any GSM cell will have 200 kilohertz bandwidth allocated in downlink and in uplink. Of course, two separate bandwidths. Uplink bandwidth will be different, downlink bandwidth will be different per cell. So there is a GSM cell configured in some area. That cell has got 200 kilohertz allocated in downlink, 200 kilohertz allocated in uplink. Now, 200 kilohertz typically represents Hz is one cycle. Basically, Hz is one cycle per second. If it is 200 kilohertz means kilo is 1000, 200 into 1000, which is equal to 200,000 symbols. We call it as 200,000 radio symbols we will be having in 200 kilohertz. What is that? We learn the deeper things at LTE time. Right now, we just try to put some numbers in case of GSM. So we have 200,000 symbols in downlink, 200,000 symbols in uplink. Okay, great. Now, by using these 200,000 radio symbols, how many data bits we could send out? How many data bits can be sent by using these 200,000 symbols, either in uplink or downlink? How many data bits can be sent? What is the meaning of a data bit? Your 1 or 0 is typically called as a data bit. 0 is one data bit, 1 is your data bit. How many such bits can be sent out by using these many symbols? Depends on something called as a modulation technique. We'll be learning these modulation techniques while we are going to go through our LTE concepts, how these modulation techniques work. We learn deeper mathematical things related to these modulation at a later stage, but it will be dependent on modulation technique. Now, depending on the GSM used modulation called as GMSK, your GSM technology use a modulation called as GMSK. Now, by using this GMSK modulation technique, One can send 2,70,800 data bits by using 200,000 symbols. How that is possible? Do we give a care right now? We don't. We don't give a damn right now because we are not learning that GMSK modulation technique, how it is going to work. Because if you spend any time on it, it is useless because it is not going to be a question for your interview or in your future learnings because none of the modern technologies are using GMSK technique. So learning that also is a waste of time. That's why we are just seeing the numbers directly. We'll directly learn whatever the modulation techniques that are used in LTE and how it is related to the data rate. We'll be learning that part. Okay, but we are not going into it. So you blindly believe me right now when I say that by using these 200,000 symbols, one could send 2,70,800 data bits. So it is little bit more than that number of symbols that are available. Okay, that's great. How? Later. We are not going into that. Okay. Now, so what is the data capacity of a slot? For example, if a mobile user got a slot allocated for him, in that slot, how much data the mobile can send out, or how much data the mobile can receive in the downlink direction, how much data the mobile can send out in the uplink direction. Mobile will always send the data out in the uplink, and mobile will always receive the data in the downlink direction from the network. Whatever the mobile sends to the network is called as uplink. Whatever mobile is receiving from the network is called as downlink. Okay. Now, how much amount of data that we can send on a slot depends on the size of the slot. Obviously, it must be dependent on the size of the slot. Why it must be dependent on the size of the slot? For example, if the size of the slot is like, we will take it as 1 second, we will take it as. If your size of the slot is 1 second, 1 second is equal to 1,000 milliseconds, that's okay. But if it is 1 second, how many bits we can send is 2,70,800 bits. Reason is when we say hedge is per second always. 200 kilohertz means you have 200,000 symbols per second. It is like per 1 second. It is. So if you have 200,000 symbols available for 1 second, if your slot size is 1 second, you will be able to send, according to this calculation, you will be able to send 2,70,800 data bits. If the slot size is um, if the slot size is 1 second, okay. Are there any voice issues? Anybody facing online?
Hello?
Yes.
No, sir. Now okay.
Okay. Just a minute. I hope it should be okay now, I guess. I think it was a temporary issues happened, might be somewhere, but I think it should be okay now. Anybody else facing this issue now? Are you getting my voice cleanly now? Can
Yes,
someone
sir. Now it's
confirm?
okay.
Now it's okay. Okay, fine. Thanks. Okay, great. Okay. So what I'm telling, so if the size of the slot, if at all, if the size of the slot is 1 second, we would be able to send out, like 270,800 data bits according to this calculation, because in 1 second we have these many symbols. So obviously you could send this much amount of data. But um, if you assume another example, like 1 millisecond is your size of the slot, how many bits we could send out? So it is simple. 270,800 divided by 1000, um, it is like giving us 1 millisecond. So into one, because we want it for 1 millisecond. So the number of bits we can send out is 270.8 bits. If if at all the size of the slot is 1 millisecond, if at all. But in reality, what is the size of the slot in GSM? Is it 1 millisecond or is it 1 second? No, it is 0.577 milliseconds. It is. Or if you want to write it in microseconds, say 577 microseconds, or um, you know, or 0.577 milliseconds. So it is little higher than half a millisecond, basically. 0.577 leads to that. Little higher than half a second, half a millisecond. Where this number has come from, why they have decided that strange number 0.577, what is the speciality with it? Does the Newton invented that number, or is there any great scientist found out that this number is auspicious or something like that? Is there any speciality to this number? There is no speciality to this number. So what this GSM body who is writing these specifications, what they have done is uh, they normally will do lot of experiments. Hey, what should be the size of the slot? So they try out with a lot of different values. They will do experiments with a lot of different slot values, and after conducting hell a lot of experiments, they finally decided that, hey, if the slot size is 0.577 milliseconds, everything is good, looking good. Your GSM mobile phones are working perfectly. If the slot size is this particular size, it is working out for us. So it is a trial and error kind of a value. So after performing lot of trial and error methods, finally they found out that this is a perfect value. So what is the capacity of a slot? A slot can send this much, 270, 800 divided by 1000. Obviously, this gives us what can we send out in 1 millisecond. But we cannot we are not looking for 1 millisecond right now. We are only looking for 0.577 millisecond. So if you multiply that with 0.577, now it gets reduced. So in 1 millisecond we can send 270.8 bits. So in one slot we can send 156.25 bits. That means in your GSM operation, if any mobile equipment gets a slot allocated to it, it will feel happy that, oh, great, I have got a slot allocated to me. So what can I do? I can send um, 156.25 bits. I can send or I can receive these many bits. I can either send or I can receive. If uplink slot is allocated, I can send 156.25 bits. If a downlink slot is allocated, I can receive 156.25 bits. In reality, there is no value for 2.25 actually, because a bit means a full zero or full one. 0.25 doesn't actually make any sense. But uh, just a mathematical calculation wise, if at all a slot is allocated for you, you can send these many bits just on mathematical terms. When we say bit means either it will be 156 bits or 157 bits. There is nothing called as 156.25 bits. Okay, fine. So now we started introducing the radio channel concept in GSM to understand the things to a much deeper level. So we have a concept called as physical channels in GSM. Another name for what? TDMS slots. So whatever these slots concept we have discussed, 0.577 milliseconds, that slot is also can be named as something called as a physical channel. Simply, they are just naming it. So for example, if you take per cell, if there is 200 kilohertz, uh, you know, 200 kilohertz bandwidth is allocated in a downlink operation for a cell. So how many slots you will be having? How many physical channels you have, or how many TDMS slots you have? Every TDMS slot is 0.577 milliseconds. Time is on the x-axis, so you have lot of slots. Slots will be continuously there for you. So similarly, even for uplink also we will have the slots continuously. So we already calculated this that every slot can send either in uplink direction or in downlink direction 156.25 bits. We have already calculated that. So these are all the slots. Okay, great. So we know this. The amount of bits that we can transmit, we have to look into it. For example, if you take 0th slot, how many bits we can transmit in GSM? Count that and tell me how many bits are these. So if you just take the numbers that are written there, so you have 142 in the middle. There is something called as 3 bits at the starting, 3 bits at the ending. If you count all the things together, we get to a value 148. 142 plus 6, 148 bits we will get. Okay, but that it is should not be 148 bits. It should be 156.25 bits. So what actually happens with the remaining 8.25 bits in GSM is there is something called as a guard time. What is this guard time? When the frequency is getting allocated to any mobile phone, before we take it that frequency from one mobile phone and give it to other mobile phone, there will be little gap in the middle. That amount of gap is actually called as a guard time. So this guard time is basically going to be a wastage. So this guard time, approximately how much amount of time that we have in the name of the god time is 8.25 bits long. That means if instead of using it as a god band, if we would have allocated it to any mobile phone, we could have sent another 8.25 bits in that space. But instead of sending any bits, we are leaving that as a gap between one slot to another slot. So between every two slots, we will have some god time that is getting wasted. Obviously that will get wasted because you have to transfer this resource from one mobile to another mobile. So you will have this much amount of guard time before the usage of one mobile to another mobile. So there will be a wastage even in case of TDMA also, but this wastage will be much better wastage than FDMA wastage, technically speaking. So when they have attempted which wastage will be better, they found out that the TDMA wastage will be much better than FDMA wastage. So that's why they stick to this TDMA wastage. They said that, oh, this got time, if we would have properly utilized it, allocated it to a mobile, we could have sent another 8.25 bits there. But we are not utilizing it. We are leaving it just like that. For example, if you have you have a house, your neighbor there, but between your house and your neighbor house, definitely there will be a wall. Obviously, there would be a wall. You know that wherever you are building the wall, that much amount of land you are wasting. If you don't waste that land, you could actually grow some more plants or some more trees. You can lay down some more trees. But you say, hey, no, I have to have a separation, and definitely I need that wall. So you got to waste this. So in the next slot, how many um, bits we could send is again 148. So after every slot, you will have these 8.25 bits of got time. After every slot, you would be having it. So this continues further like this. Every slot, this is the same situation. These 148 bits also have been technically divided into three tail bits at the starting and three tail bits at the ending. In the middle, we are going to have actual data which is equal to 142 bits. So your mobile, out of a child, if he gets one slot, he could send 148 bits. Out of that 148 also, three bits at the starting, three bits at the ending are called as the tail bits. Mostly the tail bits are almost useless. Um, Other than in some particular concepts, how many bits we could literally use is 142 bits in the middle. If at all you get a slot, you could send 142 bits, or you could receive 142 bits. That is your data. Okay, we are learning deeper concepts. So now, if you do summarize what we have learned so far, summarization will be like 2 seconds, not more than that. So in GSM, radio frequency is divided slot wise because the slot size is 0.577 milliseconds, in which time you could send 148 bits by leaving the guard band. That is what we have learned in our today's class so far. Not much. Okay. Now, mobile equipment require this slot allocation for various purposes. It requires it. So we need to allocate the slots for various mobiles for their services. So individual mobiles will be demanding these slots for performing their services like sending their voice data, sending their call related information, or to send their SMSs. We require some slots. To do anything, you require some slots because you know that when you have the slots, you can send some 148 bits. And if you want to send a SMS, you will calculate and say, hey, these many slots I require to send a SMS. You will be demanding that many slots if you want to send a SMS. For example, we can roughly calculate the number of slots required for a SMS. Typically, your SMS will be 160 characters. Each character will be 8 bits. So if you take that number and divide that with 148, because every slot can send 148 bits. So you divide that by that number. So whatever the output value you get, that many slots you require to send a SMS. Whatever the output number you get, because each slot is sending 148 bits, your total number of bits for a SMS is approximately 160 into 8. Your SMS size is 160 characters. Each character is 8 bits. Each English character is 8 bits when it is converted into digital data. I hope you are getting the logic there. So for each mobile, for performing their services, they require the slots like services like calls, SMS, and mobile is supposed to do this thing called as location area update. Yesterday we talked about that location area update. Mobile is supposed to perform that. It need to go and tell to the MSC that hey, I was there in a old location area earlier. Now I have moved into a new location area. and I am updating my location area with you. Please note down my location area. If at all I am getting any incoming calls, please search for me in my new location. Even to perform this location area, mobile equipment is supposed to send some message to MSC. That message will be always be in the digital format, will be in the ones and zeros. Of course, which MSC understands it, but it will be in the ones and zeros format. So even that location update message, to send that location update message, we require some slots. For example, let us assume that this location area update message is like 600 bits. Assume it is 600 bits. So you require about 5 slots to send that message, because each slot can send 148 bits. So if you divide this with 148, you require approximately 5 slots. 4 slots won't be enough. There will be some more bits left out. You require 5 slots. So to send your location update message, location area update. So like that, for every kind of data that you are sending, you require some slots depending on their sizes. Now, other than these individual services for each mobile, um, you have general information services that will take place in each and every cell. General information services to benefit all the mobile phones. What are these general information services for the benefit of all the mobiles? We never introduced this concept earlier. We are actually talking about it for the first time in all the classes that happened so far. What is these general information services which are going to be beneficial for all the mobiles in a um, in a network? What are those? You might not have any idea about it, but this is required. This is very much needed. Like what kind of services are this? For example, how your mobile equipment will get to understand which is his operator network. For example, your mobile is using a Airtel SIM card. Let us suppose, guys, are you guys facing any audio issues?
No, sir.
Okay,
From my side, no.
okay. Let us suppose um, your mobile is using a Airtel SIM card. Now, if you put your Airtel SIM card in a mobile phone and switch on, we expect our mobile phone to register with Airtel MSC, Airtel network. We expect that. We expect that our mobile registers with Airtel network. Now, in a geographical area, there will be all kinds of network. There would be Airtel network present. There would be Idea network. There would be a BSNL network, Reliance network. Every network would be there. But mobile equipment will must be able to find out which network is what, which network is my network, which network is not my network. Mobile must be able to separate that out, or segregate that. It must do that. That is very much needed. So how can mobile find out which network is Airtel network? To help the mobile equipment to separate that, all your networks will be broadcasting something called as a system information. They will be broadcasting 24 by 7. They will be broadcasting that, called as system information. So once mobile equipment reads this system information, by detecting in whichever slots those system information is placed. By detecting those slots, if mobile started reading the system information, mobile will be able to find out. By converting the digital data into actual protocol message, mobile understands that, oh, this network is Reliance network, I should not latch on to this network. Oh, this is Idea network, I should not latch on to this particular cell. Oh, this is my Airtel cell, because when I read the information that is present in this Airtel cell, when I read the system information present in the Airtel cell, I found out that this is a Airtel network. Based on the digital information I have decoded, I could able to understand this is Airtel network. So with the help of this system information, the mobile users will be able to segregate networks or identify the networks. So even for this service, even for sending this system information 24 by 7 to help all the mobiles coming into that cell, we require to allocate the slots to this broadcasting purpose. We need to allocate some slots. Yes, not the SIM cards will check these networks. Your mobile equipment will check these networks. SIM card is not going to have any software or radio mechanism available. It is done by your mobile phone. Of course, your mobile phone will talk to your SIM card. Yes, mobiles syncs with each frequency one by one. How it does that, we'll learn it by the time we complete these classes. We'll understand that also. So, but the mobile will keep syncing with one cell after the other cell, each frequency one by one, and from each cell, it will be reading the system information. Your mobile would be reading the system information, and then after that, only mobile finds out this cell belongs to which operator. This cell belongs to Airtel or GSM, sorry, Airtel or Reliance Jio or BSNL or Idea or Vodafone or whatever. It will be able to find out that. We learn that how that happens. We are not even going into that level right now. We are just understanding it at higher level right now. So we are recognizing that for providing this system information broadcasting, we require some slots. We are recognizing the need. Same way, we need some slots to be allocated for sending incoming call details to all the mobile phones. That means each mobile equipment is going to get some incoming calls. Where do you send these incoming call details? Again, we require some slots for that purpose, for incoming calls sending also, because when the mobile equipment is in idle mode, he is not doing anything, he is in idle mode. Network must tell the mobile that, hey man, there is an incoming call for you. We need to send this incoming call related information by using some special slots. We typically call it as a paging slots. By using these paging slots, we'll be distributing this information to the mobile phones, whoever are operating that network. Next, we require some slots reserved for purposes like self broadcasting. What is the meaning of self broadcasting? For example, you can advertise information about what is the local temperature in that particular area. You can distribute these kind of details, whether there is any rain expectancy in the next 3 hours. You can send any of these kind of details, or operator can use these common broadcasting service slots and sending advertisements. In some restaurant, lunch is ready, you go and eat, it is only 100 rupees, something like that. So self broadcasting, you can reserve some slots for sending these general information, which is not like specific to any particular mobile. It is general details, which may be like, you know, maybe used by many mobiles, maybe may not be, but it is common for everybody. These are called as common services. So all these three things, system information that we have to broadcast, which explains network related details, or incoming call related information sending, or your self broadcasting like advertisements, weather related information, etc. All these things will be classified. We can call it as common services, common for every mobile. But there are some dedicated services, call data, SMS data, location area updates. These are all going to be individually applicable for each mobile separately. It is not like for many mobiles. It is not that way.
Sir, actually here, who allocates the slots?
Sorry?
Who allocates the slots?
Yes. Who allocates it? Do we come to that part? But we are just recognizing the need for the allocation right now. Who allocates it, we'll find out in a minute. Now we are going into the next level concept. Let us call each of these services which requires the resources. I hope now you understood what is the meaning of a resource from GSM point of view. From GSM point of view, resource is something which is nothing but a time slot is a resource. Your TDMS slot is a resource in GSM. So for each of these services, we require to allocate the resources. Now, all these services in GSM point of view, they have called it as logical channels. It is just a name. This logical channel is just a name, some technical name, that's all. For example, system information that we have to broadcast 24 by 7 in a cell to help out the mobile phones to detect the system related details like the operator related details, etc. So that system information, they are just giving the name as broadcasting channel or BCCH. It is a name. So we are just giving name to each kind of data. All the data is ones and zeros, but for each piece of ones and zeros, or each group of ones and zeros, we are giving a name. So this system information data is now called as BCCH data or broadcasting channel data. Just a name. If they are giving a name, there is no harm in it. Let them give the name, not a problem. Your call voice data, if you talk to somebody, you that is called as a voice data. That voice data is called as traffic channel data, TCH. It is going to be named as. And if your mobile station is communicating with the network, like requesting things from the network, hey, I want this, I want that. If your mobile is communicating with the network, that is called as control channel, or also named as SDCCH, standalone dedicated control channel. Will be naming that as. So if mobile sends any digital data to the network, that kind of data is called as SDCCH data or control channel data. So these are all different names for different types of data that the mobile is generating. So incoming call information is called as paging channel data, PCH data. Your cell broadcasting data is called as CBCH data, cell broadcasting channel, CBCH data. Okay, why the hell they have to give these kind of names? What is wrong with these people? Are these guys mad to give these name? No, they are not mad. They wanted to have some kind of an organized documents while writing the technical documents. You are supposed to give some technical names for everything instead of using human language. We won't be using human language. We would be using some technical name. That's why they are just giving some technical name to each piece of the data. It's okay. We are not mad with that. That's fine. So they have understood the need that, hey, when we are writing the technical documents, it'll be better if we have all these technical names. For example, when you see a plant, you just call that plant with its human name. But when you go into a scientific lab, they will never be using a human name there. They will be using the scientific name of the plant, because that makes sense for them, because with the help of that scientific name, you are like conveying its chemical properties, or you are conveying its biological properties. Okay, so it makes sense to use the technical name in the lab, not use its general day-to-day human name. Same concept here. So whatever the data the mobile is going to generate or receive, they have classified the data into various kinds, and they have given a name to each kind of data. These are the names that for each type of data that the mobile is either receiving or sending out. But what did we get is, for each kind of this data, we need to allocate some slots. We must allocate the slots. Slots are needed for to send any of these data. All these types of data is digital data, ones and zeros. To send that out, to send the data out or to receive the data, we require some slots. Slots are our need. That is the physical thing. Okay, great. So all these logical channels require physical slots, or physical channels are the physical slots to transfer their information. Definitely. So you require one slot to be um, allocated for all these types of channels. So we can allocate it this way: BCCH, SGCCH, TCH, TCH, PCH, CBCH, like that. One slot allocated for one type of channel. We are allocating it. Or we could allocate it this way: one TCH, SGCCH, BCCH, TCH, CBCH, PCH. You could allocate it in any which way. That's your choice, in which way you want to allocate it. It's absolutely, the choice is left out for you. But who is supposed to allocate these channels to these slots? Who is supposed to allocate it? No, the organization which is writing or which is developed this GSM system, what did they do is, they thought that, hey man, we cannot let each and every operator decide which slots must be allocated to which channels. If we give that kind of a freedom, operators will be using it in their own way, in a zigzag fashion. Instead of giving the freedom to operator, let us standardize it. So we'll make sure that every operator uh, allocates the slots in the similar manner, so that all the different mobiles developed by different companies, they will not have any problem in reading these slots. So these mobiles could be able to easily detect like which slots are for which operation. If we standardize it, it will become easy for us. If we don't standardize it, it will be difficult for us to figure out which slots are for which operation. Now, worldwide, there could be like tens of companies which are developing your BTSs, your towers, which are transmitting these radio slots, transmitting these radio frequency in terms of slots. They will be transmitting it. There will be hundreds of mobile phones which are developed by hundreds of companies who will be receiving these slots. But everybody, there are 100 different mobile phone companies. There are tens of your BTS manufacturing companies. But all these mobile phones, all these BTSs must have a common understanding. If they wanted to have a common understanding related to these slots, somebody must standardize it. Now, what is the meaning of standardizing? We have to talk about it a little bit. What is the meaning of standardization? You've gone to a computer shop. You ask that computer man that, hey man, I need a USB stick. He said, okay, which one you want? I need a Samsung USB stick. Okay, he gets you all the possible Samsung USB sticks and say, hey, this is 500 rupees, this is 1000, this is 2000, this is the most expensive one, which is 4500 rupees. So your wish, which one you want to buy? You buy one thing, you get home. No, you get home, that's perfectly fine. How the hell are you sure that the USB stick that you are buying will actually fit into your computer's port? How are you sure when you are buying it? You are damn sure it will fit into your computer's port. How are you sure? What is the guarantee? Because the USB stick, the port size is standardized. The company which is manufacturing your laptop know what should be the uh, female port size, and the company which is manufacturing the USB stick like Samsung, that company people, they know what should be the size of the USB stick. They know those sizes because they have been standardized by some organization that USB 2.0 stick size should be this, USB 2.0 port size should be this, USB 3.0 port size should be this way. So they have standardized all those sizes. Because they have standardized the sizes, you are buying a standard port or standard USB stick, you know that it will stick onto your device. So I hope you are understanding what is the meaning of standardization. So here we have to play with the standardization. You have to take it for granted that, hey, a Samsung mobile will work differently, Nokia mobile will work differently, and you know, some other company's mobile will be working differently. You should not do that. Every company should be having the same standards followed. Then only you could operate with one operator's network. Because operator is not going to design their networks depending on, oh, for Samsung mobile phone my network will be working like this, for LG mobile phones it will be operating like this, for some other company's mobile phone my network will be operating like this. No, hell no, we don't do it that way. Our network must be operating irrespective of what is the brand of the mobile. We must standardize it. So this GSM organization called as ITSI, European Telecommunication Standard Institute, who have developed these GSM standards, they have done lot of experiments and they found out that, hey, I think we should fix a particular mechanism of allocating these slots to different channels. We should standardize it and we should force that all the operators follow this standardized mechanism. All the mobile phones also know this standardized mechanism. We should standardize it so that it will become a common criteria for every mobile manufacturing company, every BTS and PSC manufacturing company, so that everybody will be working on a common ground. That is very much required. So this ITSI company, European Telecommunication Standard Institute, they have standardized it indeed, which slots must be allocated to for what logical channel purposes. So is it this way allocated or is it this way? Answer is no, not these both the ways. I'm going to definitely show you in which way actually the slots are allocated for different logical channels. I will be showing you in the coming up slides. But even before I go it, I'm confidently I can tell you that this is not the way the slots are allocated for different channels. This is not the way. Just to give you an idea, I'm telling you that we could have allocated it any which way. But are these the ways the slots are allocated? No, they are not. I can definitely tell you that they are not, because I know in which way the slots are standardized for different operations. I know it. That's why I'm telling you this is not. But I just put this slide for your basic understanding of the things. So, what is the allocation technique that this European Telecommunication Standard Institute literally followed? What kind of a technique they have followed? So, we need to understand that first. Okay, so we have these slots. So, um, so what happens is these slots will actually be moving um, from left to right. They would be moving basically. So with the time moves, you will have slots coming up. But for allocating these slots to different purposes, what your ITSI wanted to do is they would like to allocate some numbers to these slots so that the allocation mechanism will become easier. If we give some numbers, we give some just some kind of a numbers to each and every slot. They started thinking, hey, can we give the slot numbers like this way? They thought. But later they found out that this is a bad way, because the slot numbers will be forever increasing. After 2 hours, slot number that will be running is 2,75,087,000, 855 slot number will be after 2 hours. Reason is slot size is only 0.577 milliseconds. In every second we will have around approximately around 2000 slots in every second. In every minute you can multiply that with 60. You see, you it keep going like that. So it will be lakhs and lakhs of slots. So we cannot give continuously increasing numbers. Instead, they thought that, hey, we should allocate these numbers to these slots in repeating order 0 to 7. We should repeat these slot numbers. 0 increase up to 7, 0 increase up to 7, 0 increase up to 7. Why the change? Why? How this is going to help us? It will help us definitely. For example, if you take the dates present in a calendar, you will understand the concept. The dates present in your month, it will be like from 1 to 30 or 1 to 31. After it reaches the maximum value 31, then the next month calendar, the date again becomes 1. Because it makes sense from the human utilization point of human usage point of view. You can easily tell that, hey, please come on, June 17th to our house. I'm inviting you on June 17th. It makes sense for you. So June is the month name, 17th is the date. You will never tell that, hey, please come to my home on 15,715 date. We don't be like so much happy with that numbering if you literally follow that kind of a numbering. So they have called these 0 to 7 repeating things as something called as frames. So time wise, it will be moving in the frames. These are called as actually frames. Each frame will be having 7 slots. Just like every week we'll be having 7 days, and the weeks will be repeating. Just same kind of a concept. Number of slots we'll be having are 8, numbered from 0 to 7. We'll never start the numbering from 1, because in digital technologies we'll always use 0 as our first number. So 0 to 7 are there 8 numbers totally, 8 slot. Each of these 8 slots are called as frames. Frame number 0, frame number 1, frame number 2. So I can tell my mobile equipment that, hey, man, I'm allocating you a slot, frame number 13, third slot, I'm allocating you. I can tell this. If we have this kind of a numbering, I can tell this to my mobile. Or I can tell my mobile that in frame number 27, I am allocating you slot number 6, I'm allocating you. So the advantage of having these frame numbers and slot numbers is you can convey some kind of a logic to your mobile, which slot you are allocating for his purpose. You can convey that. That is the purpose of numbering these slots with respect to the slot numbers and grouping the slot numbers in terms of 8 units, and you are giving some frame number to that, frame number 0, frame number 1, frame number 2, etc. That's the purpose. Okay, great. So because it becomes easy for the BTS and BSC to talk to the mobile equipment and tell the mobile that I am allocating so and so frame number, so and so slot for you. So that is why they have started giving some, uh, grouping of the slots. They have called it as a frame number, and these slots are numbered from 0 to 7. It makes sense. It will become easy for allocating when you do it. For example, whenever mobile begs for the resources from um, your BTS or BSC, tell the BSC that, hey man, BSC, please give me some resources, some slots for my operations. I need some slots. Can you please give me some slots? Your immediately BSC will come back to the mobile equipment and tell, yes, I'm allocating you some slots. uh, I'm allocating you frame number 25, 26, 27, 28. I'm allocating you in these 4 frames. I'm allocating you one slot. In every frame, I'm allocating you one slot for continuously for 4 frames. So please take those 4 slots. Those are yours. Nobody else will use it. I guarantee you. How can I guarantee you? Because there is nobody who can use my slots without me allocating it, because I am the boss of the GSM network. Your BSC is the boss. Whichever slots BSC allocates it to any user, the users are supposed to use those slots. You are not allowed to go away from that arrangements. You must stick to that arrangements, whatever that are proposed by your BTS, your BSC. So you should stick to it. There is no other choice for you. I hope you're clear on the things that we have discussed so far. So number of slots we are going to have in GSM are 7, starting from slot number 0 to slot number 7, which are technically named as time slot 0 to time slot 7 in every frame. And every frame size is typically 4.615 milliseconds. How did we arrive at this time? Because each slot duration is 0.577 milliseconds. You have to multiply that with 8. When you what you get to is this value, 4.615 milliseconds. Okay, so they have done a beautiful arrangement. So we understood about the arrangements today. What arrangements we understood? How the organization called as ITSI have done the arrangements. What arrangements they have done? They have decided to use 200 kilohertz frequency for uplink and downlink. Very good. And they are going to allocate these grouped as divided as grouped as frames, and whenever any slot is allocated for any user, that information will be conveyed to the user. So and so frame, so and so slot number that is allocated to you, it would be conveyed to the mobile user. All the arrangements are done, but in reality, how that the frame arrangements will work out, how that slot arrangements will literally work out, we need to understand that. We need to study that. How it happens, where is that it's a standardized mechanism of actually allocating the slots to for different purposes. So we need to get to study that. I will show you that arrangement just as a glimpse of it today, but we are not going to study that today. We will be studying that tomorrow. So this is the standardized arrangement that ITSI has made for different types of channels, like which channels are occupying what slots. Again, this is only for downlink arrangement. In the downlink, how the different types of data can sit in different slots. This is the arrangement that ITSI has made for downlink. But we have a different arrangement for uplink. In uplink, we have this kind of arrangement again for uplink. Okay. So, so we have done some special arrangements. So who standardized this? Your organization, which is defining the GSM standards, they have standardized it. So every BTS, BSC will be working on this. Every mobile equipment knows this arrangement. That every GSM cell will be organizing with this arrangement. But how to work with this arrangement? How literally this complex arrangement will work out? We have to study that. We will be looking at that is the most interesting part. So we'll be looking at most interesting part with the help of a GSM call. Okay, we will study that in tomorrow's class. We will be looking into this GSM call flow, end-to-end call, how the mobile equipments will be able to talk to each other, how the resources are nothing but the slots will be allocated to the mobile users. So we will be studying that in our tomorrow's session. So that's the most interesting part left out for tomorrow's class. Great. So I will end that in here. I'm going to use another 5 minutes to get back to our earlier thing.
Hello, sir.
Yes.
So tomorrow it will be the last.
No, tomorrow we have a session. Only Sunday will be off for us. We'll be having the
Okay.
6 days a week sessions. So Saturday also we'll have the session.
Okay. Okay.
Okay. Um, so what I'm going to use the next 5 minutes for, in our first module, we have this two tools called as GNS3 and Vaishak. Yesterday I showed you the tools, and the same tools we would be using in the sixth module also, which is the OSA module. We'll be using this GNS3 and Vaishak tools. We would use it in sixth module as well. Great. Now, in module 2 and module 3, both are theory modules. We will be learning the actual protocols in both LTE, LTE Advanced and VoIP, SIP and IMS. There won't be any practicals in these two modules because we will be learning the test cases and we'll be learning the protocols and how the protocols are communicating with each other, what information will be present in which protocol. That kind of details we'll be learning in the second module and third module. Literally, there won't be any tools in this second module and third module. Only protocol related information we will be learning in both these modules. Great. But once we learn these LTE, LTE advanced and VoIP IMS related protocols, now we need to test that protocols. So the testing of the protocols would come in this fourth module, which is called as LTE IMS protocol testing practical part. So this is our practical part, LTE IMS protocol testing practicals. Okay, so how do we do the practicals? How do we test these LTE protocols or IMS protocols? How do we test these protocols? Your telecom protocol testing in any company can actually be done in two different ways, called as script-based and tool-based protocol testing. It can be done in two different ways. So what is the difference between these two different mechanisms, script-based mechanism and tool-based mechanism? In script-based mechanism, you are supposed to write some script by using some scripting language. You will be using a scripting language and you would be writing some script, and with the help of that script you will be able to execute the test cases. You write a test case script, and when you execute the test case script against a product, now you will be able to test that product's protocol. You will be able to test that product's protocol by executing a test script. Of course, you have to write the test script. That is the difficulty. Once you execute, you will be able to generate a log file. You will analyze that log file by using your protocol knowledge, and then you come to a conclusion about whether that particular test case is passed or failed. If the test case is passed, you will go and talk to the development team and say that, hey, you have developed your software really good. Your product is perfectly working. But when you analyze the log file, you found out that the test case is failed. You go to the same development team and tell the development team that, hey man, whatever the product software you have developed, the protocol is not working correctly. The protocol is literally failed, utter flop. So when I executed my script against your product did not behave the way that I am expecting it to behave. I found out that with the help of my script. So your product is not working correctly. I'm raising a bug report. You can tell this to your development team. Now, how do we write this script? What will be there inside your script? How your test case will be able to work? All those things we learn later when we are doing this. But I'm just explaining the concept. So, script-based protocol testing. The second mechanism is tool-based protocol testing, where you don't need to write even a single piece of script. Some companies will be developing these tools. The tools will be able to run the test cases on their own. Only the thing is, you need to install the tool software, and you need to just click here and there and run a test case. You don't need to write anything. You need to choose what you want to execute, and you will execute it simply. You will be clicking a button here, a button there, and your test case will get executed and a log file will get generated. You will be able to analyze that log file, and you can come to a conclusion about whether your test case failed or passed. You don't need to write a single piece of code when it comes to tool-based protocol testing, because the tool is developed in a sophisticated manner by some company. You are utilizing the tool and you are performing your testing duties without writing a single piece of code. Now, which which method companies will use? Companies will use both methods to do the protocol testing. Some of the companies will use script-based protocol testing. Some companies will use tool-based protocol testing. Now comes the question: which one we have to learn? Answer is we need to learn both, because 70 to 80% of the companies will use the script-based protocol testing mechanisms. 20 to 30% of the companies would use tool-based protocol testing mechanisms. So because we should not be losing any job, we must be able to understand both the mechanisms. We should be ready to understand both so that you will not miss out any opportunity, any interview you can attempt. Okay, great. What is the next thing? So we need to understand in each of these mechanisms what we are going to do. So today we are going to look into script based. Tomorrow I will show you the tool based mechanism. So in script based, what do we do? In script based protocol testing, we are going to learn two scripting languages for testing the protocol testing called as TTCN3 and Python. Why two scripting languages? Is one scripting language not enough? Why are we learning two scripting languages? What is the need for that? That question pops into our head immediately. The answer for that is this script called as TTCN3 scripting language is like mandatory scripting language to perform mobile equipment side protocol testing. That means if at all you are doing, if you are going to work for a mobile manufacturing company to test their mobile phone protocol software, it is mandatory to use TTCN3 scripting language. Why it has become mandatory? What is so special about it? Because the organization which has developed the LTE standards, that company called as 3GPP company who developed the LTE standard, they have decided that hey, mobile phones must be tested with this TTCN3 scripting environment. They have standardized it. So this 3GPP is the continuing body for the ITSI, the old ITSI body only now converted into 3GPP. So these guys have told that the mobile equipment protocol testing must be done by using TTCN3. There is no choice we are giving related to that. So we can find out that information from this website called as ttcn3.org. TTCN3 website, official website developed by ITSI, European Telecommunication Standard Institute, which is indeed a part of 3GPP. Great. So, because half of the jobs will be on the mobile phone protocol testing, we cannot ignore this TTCN3. We have to learn it. Great. So, what do we need to do to learn it? We have to use one of the tool which can actually run TTCN3 scripts. We must use one of the tool which can run the TTCN3 script that you develop. So how many tools are available to execute TTCN3 script? Only a few tools developed by few companies. So those tools are listed here. There are about 7 to 8 tools available in the world which can execute TTCN3 script. One of those 7 to 8 tools only we can use. We cannot have any other tools because these are only the companies which are developing those tools. There are no other companies that are developing TTCN3 executable tools. Any company in the world must use one of these 8 tools. That's all. There is no question about it. Now, which tool that we are going to use? We are going to use this tool called as developed by a company called as Elvier. This Elvier is a Estonia company which is in Europe, um, which develops this tool for TTCN3, as you can see over here. So they are specialized and they developed one tool, TTCN3 tool. So if you go into the TTCN3 section now for this company, you can see these details over there about that tool. It would be typically costing you around 6,000 euros to buy one license of this tool, which is approximately equal to 6 lakhs. So you won't be able to buy this tool to practice. And most of the training centers in India, they will never be able to get this tool because for the mere 25,000-30,000 that you pay, they won't be able to get this tool and give the license to different students. Not possible. Okay, great. Then how T Cloud is getting it? So we are not even buying it because it will never be commercially feasible to buy this tool and give you this tool for your practice. Not possible because you're not paying that much amount of money. So how then we are getting it? We are getting it because we made a tie-up with this Elvier. So what is the tie-up? So we made a tie-up with them because of the tie-up. The agreement is that we provide the training to all the Elvier clients in India. Whichever company buys the LVR tool, we go and train them and we set up the lab and we bring up the lab environment for them. So that kind of a service we provide for all LVR clients in India and APAC region, Asia Pacific region. So you can see our logo here. This is the T-Cloud logo that you can see in LVR website. So because we have this relationship with them, even though we are not buying the tool, we have the tool available, which we could actually give this tool for your practice for TTCN3 script executions. Nobody else would be able to get it because only these kind of big companies will be able to get it. They are buying it, of course. Okay. So we will be learning TTCN3 and we will be practicing our TTCN3 script by using this tool called as LVR testcast tool. So this is first part. The second part is the Python. Python is a very popular scripting language which is being used worldwide in many organizations and many companies to do the protocol testing, especially on the core side and the IMS side. So if you take our protocol testing, it will be into three categories in protocol testing. What are those three categories? The UE side protocol testing, that is the radio part, your core side protocol testing, and IMS side protocol testing. When it comes to UE side, there is no other option but to use TTCN3 because it is mandatory. No way, no other mechanism. We should use it. But when it comes to the core protocol testing or IMS protocol testing, we could use either TTCN3 or we could use Python because there is no condition now here when it comes to Python. So Python could be used for your core side protocol testing and IMS protocol testing. Because TTCN3 is costlier, some of the companies, because Python is an free environment, so some of the companies will prefer to use Python as a scripting language when it comes to core protocol testing and IMS protocol testing, as there is no mandatory criteria that is applicable for core and IMS. It is not mandatory on the core and IMS part that you must use TTCN3. No, not required. So, so it is like a division. So a lot of projects, half projects will work on TTCN3, half projects would be working on Python. Can we avoid any of these two things and get a job? No. We must require both so that we'll not be losing any opportunities. So that's why we have decided to teach both these things. Now, what do we teach in Python? Where do we teach this Python? This Python will be teaching in a Linux environment. We'll be teaching this in a Linux environment by using a tool called as Oracle VM VirtualBox. We'll be simulating that by using our Windows operating system. So we'll be using this Oracle VirtualBox for learning our Python. So this is the Linux environment where would be learning Python. Why Linux environment is preferred over Windows environment? Some of the transport protocols are easy to simulate in Linux when you compare it with the Windows. Windows doesn't support some of the transport protocols. So that's why for telecom protocol testing, Linux is preferred compared to Windows. So we'll be using Linux. Just coming up, just hold on, guys. So this is your the Linux environment. So you write all your everything, and mostly we'll be learning most of the things in the command prompt. We'll be executing all the things in the command prompt by writing the scripts. So um, for all your different batches, we'll be having this script taught by writing the scripts in this Linux environment and executing it in the Linux environment and send the protocol messages and capture the protocol messages, and you will be able to in the Linux environment. Okay. So we will be learning Python end to end, starting to bottom, all the concepts we will be learning in Python. Exclusively, we will be learning these parts in Python. It is Linux based. We'll be learning Python 2 as well as Python 3, and we'll be learning how to work with different transport mechanisms in Python, how to develop the coder decoders, how to work with multi-threading concepts, and how to develop the APIs that are required for communications, protocol communications will be done with APIs, application programming interface. It is called as how to develop the small APIs to communicate between the protocols. So we'll be learning that part in Python. So TTCN3 is also Linux-based environment. TTCN3 also is Linux-based, and Linux machines only would be running, and in the Python also would be running on Linux-based environment. Both would be running on Linux-based environments for protocol testing. So this is the script-based mechanism, how the telecom protocol testing can be done with the script-based. So I would stop here for today. Tomorrow I will tell you what is the meaning of tool-based, and I will show you all those tools, which tools we are going to use in tool-based mechanism to perform the protocol testing. I'll be showing you those tools as well. Okay, that part we'll catch up in tomorrow's session. All right.